This is a training module on the Avago Technologies Optically Isolated Sigma Delta Modulator, ACPL-796. Welcome to the training module on the ACPL-796J. This training module gives you an overview introduction to features and applications of the Sigma Delta Modulator. The ACPL-796J is a 1-bit second-order Sigma Delta modulator which converts an analog input signal into a high-speed data stream with galvanic isolation based on opto-coupling technology. The ACPL-796J operates from a 5-volt power supply with dynamic range of 80 dB with an appropriate digital filter. The differential inputs of plus or minus 200 millivolts, full scale is plus or minus 320 millivolts, are ideal for direct connection to shunt resistors or other low-level signal sources in applications such as motor phase current measurement. The ACPL-796J is ideal for use in industrial applications such as HVAC systems, conveyors, servo motors, and a wide range of industrial automation applications. The ACPL-796J is designed with digital inputs and outputs that are compatible with systems powered by 5 or 3 volt power supplies and works under a wide industrial temperature range. With 0.5 millimeters minimum distance through insulation, the ACPL-796J provides reliable double protection and high working insulation voltage, which is suitable for fail-safe designs. Based on an advanced low-power CMOS process, the ACPL-796J uses an external clock that allows synchronized data conversion between the current sensor and controller to help motor control designers eliminate complex design processes in data and clock reading. Moreover, the ACPL-796J is designed with digital inputs and outputs that are compatible with systems powered by 5 or 3 volt supplies and works under a wide industrial temperature range. The main function of the modulator, optocoupler, is to provide galvanic isolation between the analog signal input and the digital data output. Modulators deliver high noise margins and excellent immunity against isolation mode transients. With 0.5 millimeters minimum distance through the insulation, the analog input is continuously sampled by means of sigma delta oversampling using external clock, coupled across the isolation barrier, which allows synchronous operation with any digital controller. The signal information is contained in the modulator data as a density of ones with a data rate of up to 20 megahertz, and the data are encoded and transmitted across the isolation boundary, where they are recovered and decoded into high-speed data streams of digital ones and zeros. The original signal information can be reconstructed with a digital filter. The serial interface has a wide supply range of 3 volts to 5.5 volts. In this page, some of the important definitions relevant to Sigma Delta modulators have been defined. They are integral nonlinearity, INL, differential nonlinearity, DNL, offset error, and signal-to-noise ratio, SNR. This is a continuation to the previous page. Here are the definitions of signal-to-noise plus distortion ratio, SNDR, effective number of bits, ENOB, isolation transient immunity, CMR, have been explained. The differential analog inputs of the ACPL-796J are implemented with a fully differential switched capacitor circuit. The ACPL-796J accepts signals of plus or minus 200 millivolts, full scale 320 millivolts, which is ideal for direct connection to shunt-based current sensing or other low-level signal sources applications such as motor phase current measurement. An internal voltage reference determines the full-scale analog input range of the modulator, plus or minus 320 millivolts. An input range of 200 millivolts is recommended to achieve optimal performance. This page shows the typical performance curve of the modulator device, input current versus input voltage, and signal-to-noise plus distortion ratio versus input voltage has been shown. The ACPL-796J isolated modulator optocoupler uses sigma-delta modulation to convert an analog input signal into a high-speed single-bit digital data stream. The time average of the modulator's single-bit data is directly proportional to the input signal. This evaluation board allows direct modification to the interface IC in order to achieve different levels of performance. It also has a real-time display of the converted data on the terminal screen. A typical three-phase induction motor drive, shown here, first rectifies and filters the three-phase AC line voltage to obtain a high-voltage DC power supply. The output transistors then invert the DC supply voltage back into an AC signal to drive the three-phase induction motor. The motor drive commonly uses pulse width modulation to generate a variable voltage, variable frequency drive signal for the motor. High-performance motor drives usually incorporate some form of current sensing in their design. In the typical application circuit shown here, the ACPL-796J is connected in a single-ended input mode. Given the fully differential input structure, a differential input connection method is recommended to achieve better performance. The voltage from the current sensing resistor or shunt, RSense, is applied to the input of the ACPL-796J through an RC anti-aliasing filter R2 and C2. And finally, a clock is connected to the ACPL-796J and data are connected to the digital filter. The input currents created by the switching action on both of the pins are balanced on the filter's resistors and cancel out each other. Any noise induced on one pin will be coupled to the other pin by the capacitor C and creates only common mode noise, which is rejected by the device.